Well, thank you for being with us today, and hopefully we'll have an interesting discussion around this fascinating topic of the grid of the future. And well, my name is Alberto, and I will be the moderator on this panel. And about the grid, is the backbone of the energy transition. How many of you, by the way, work in the energy sector? Hands up. And how many of you work outside, not in the energy sector?
Solo queda uno.
But from others, okay, good. It's 70-30. But it is really the backbone of the energy transition, and it won't work without it. The thing with the grid is that it was set up, the grid as we know it today, it was engineered nearly 100 years ago for a different system, for central, large-scale power plants, controllable, that you can go up and down like gas and coal or hydropower, where you can control the output. It was set up for one-way flow of power from the production to the consumers, and it was the energy transition is more or less exactly the opposite. It's small scale, distributed, decentralized, weather dependent. You cannot turn on and off the wind or the sun. And at the same time, we have to make it all work. So the basis for the design of the grid today has completely changed. And some people are really wondering, is the electricity grid fit for the transition? And even some fear that can it become a bottleneck and really jeopardize or delay the energy transition? But we have here today 4 masters in the energy transition. Thanks for coming, Micaela, Gabriel, Carlos, and Robert. And so I'm sure they will give us answers to these kind of questions. Let me start with Gabriel.
Okay.
You are leading an energy revolution you're leading EDP business to B2C sales.
Mm-hmm.
And you are completely disrupting the market with completely new propositions for your customers. Solar, produce your own energy, batteries, e-mobility, and also flexible tariffs. But you also have some challenges with the grid, right?
Well, first, thank you very much for the invitation, Alberto. I would like to start the answer wearing the hat of the consumer. I think is right now is something that we can all feel every day. So today in Spain, we pay around 200 euros per megawatt hour the electricity from the grid, okay? But while if you install in your rooftop, in your home, a solar panel, you will pay, instead of 200, you will pay 40. You will pay 40 for 30 years, okay? So solar energy is not that it will be, is likely to happen. It will happen, and it must to happen for the sake of a cleaner and cheaper energy. So it's true that solar energy, batteries, heat pumps, EV chargers are kind of disrupting the network, can disrupt the network. Especially when the penetration is high, it can impact the stability of the grid. It can provoke flickering, voltage drops and another type of problems. Also, it is true that countries with high penetration, like Australia or regions like California, had serious problems with solar and the grid. But I think that Spain is different. I think that also part of Europe is different. Why Spain is different? First, because when something is going to happen, it cannot be called a risk. It can be called a fact. So solar energy is going to happen in Spain. Spain is the country with the highest radiation in Europe. So it will happen, and actually is the biggest opportunity that we have in Spain to clean our economy and to make it more competitive. So first, it will happen. Second, the Spanish low voltage grid is, I would say, particularly strong compared with other countries. So this means that we're going to have at least 2, 3, 4 years until the moment when the real problems are going to come with the grid. So it's not much time, but it's time enough. So unlike Australia or California, that they were really pioneers in this, and the problem exploded in their faces. So we, Spain, or part of Europe, we have time. We have 2, 3, 4 years to react, to prepare our grids, and at the end, to be ready to leverage probably the most profitable revolution in Spain, which is the energy revolution. So yes, might be a problem, but we have time to solve it.
Okay. Well, it looks like one quite tight, 2 to 3 years, but you know, we're good at this in Spain, right? Micaela, you have been many years a wind pioneer and a wind champion, both on and offshore, right? You more or less invented the offshore industry, and greatly so. But for the last couple of years, you have been working with the strategy of green hydrogen for GE. Can you tell us why is hydrogen so important for the energy transition, and also what are the main challenges you see in integrating green hydrogen and wind into the network, into the grids?
Okay. Well, also thank you to South Summit, to everybody for being here, and Alberto for the introduction. And we have talked about energy transition, right? And I would like to talk about the concept of what we're calling the energy trilemma, right? Because what we need to do is we need to assure affordable, reliable, and sustainable energy, which is the backbone of society, civilization, and our economy. Now, we want to do this so that future generations can continue developing. And that's why we talk about affordable, reliable, and sustainable. We already have seen that we finally have a consensus in the world that we need to mitigate climate change. And we know that it requires immediate action. We also already have sort of a North Star, because the IEA has published its estimates that says that we need to quadruple the amount of wind and solar from here until 2030, already in this decade. And if we do it right, then by 2050, we're going to be looking at an energy system where 40 to 60% of our energy needs are going to be covered by renewable electricity. And then you're going to have more renewables that are going to be powering electrolyzers that are going to produce hydrogen. And the green hydrogen is going to solve the needs of those segments of the economy that can't electrify. And it's also going to serve a role balancing our energy needs seasonally. So when you're talking about hydrogen, you're really talking about sector coupling. And that's a big, for anybody, it just means that we can't only keep talking about 100% renewables on our electricity grid. We can't forget that there are other energy needs that also need clean fuels. So that's why we start talking about this idea of sector coupling. It's not only electricity grid, it's gas grid, and it's the digital grid, all working together. So hydrogen is basically an energy vector that's going to complement the renewables-based system that we're going to see in future. I don't think it'll necessarily be happening this decade. This decade, we need to focus on the technology that we have right now. So I see 2 tracks, right? We already have technology. And in the case of wind, it's already affordable against fossil fuel alternatives and solar. So what we need to do is we need to massively deploy this throughout this decade. The challenge we're going to have is that in all regions, the grid is not necessarily ready. And I'm sure we'll have experts talking about what can be done. And the challenge is that we also need policy and society to truly cost the full cost of pollution, right? And then in parallel, while we're massively deploying renewables and we're strengthening our grid, we need to scale up green hydrogen so we can bring down its cost. And then we can start seeing it as an energy vector that complements renewables in the next decade. So this is when it's going to take its major role, because hydrogen, we already know we have the technology that allows us to use it as an energy vector. We can transport it as a liquid on a ship. We can transport it as a gas in a pipe. So we can use it as a feedstock for industries that have energy needs that we can't electrify. Yeah. We can also use it to power and to heat our buildings. Or we can use it as a storage element for seasonal, it can store renewable electricity for days, for weeks, maybe even for months. So we need to be working on that already, so that right now, focus on what we have, scale up the hydrogen, and then it can be a part of the energy mix in the next decade.
Yeah, interesting, thanks. And Carlos, you're deputy director for electricity in the Ministry for the Ecologic Transition in Spain. Have served multiple ministers' cabinets over the last decade or so. Electrical engineer and also studied an MPA in Columbia. A really smart guy. How are you going to figure out all of this? Because, I mean, electricity networks are heavily regulated. So I think if we want to see a revolution in networks, we inevitably will have to see a revolution in regulation as well to enable this. Share some insights with us about this.
Yes, thank you, Alberto.
Yeah.
And that's correct. As Gabriela and Micaela said, the energy sector is undergoing a huge transformation in the next few years. And in this, but at the same time, the energy sector has always been a very regulated sector. So it's especially for those activities in the related to energy, like the distribution, the operation of grids. It's something that has always been very regulated. The income of the distribution companies is set by the government or the regulator. And now they face a huge challenge because the grid has to accept a lot of energy, and as you said, that it's not coming just from top to bottom, big power plants that serve the customers at the end, but also at the end of the grid, in the low voltage grid, you have a lot of production going on, solar, wind, and so on, and also at sometimes even you have the electric cars that they are going to consume at some times, but even at different times they can put the power to the grid from the batteries. So there is a huge transformation of the role of the grids. And therefore, there has to be a change in the regulation of these grids and how the companies that manage the grids have to operate them. Until now, they were paid, the distribution companies, they were paid for building the grid and operating it. So, and that was just the role. But now they have also to receive an incentive to operate it in a way that they can integrate as more renewables as possible, that they can give more flexibility services to the customers and the grids as possible. And all of that has to come from the regulation, because the companies are not going to do it just by themselves, because they are in a regulated business whose activity is, well, is set by the regulators.
So, yeah, we are up for an interesting time, regulatory-wise. Absolutely. Well, I mean, you're the grid maestro of the panel, right, Robert? Head of Innovation and Industrialization at Enel Networks, which is the largest private operator of electricity networks worldwide, and second overall after the Chinese grid, probably, right? Yes. So, well, listening, you know, to our dear friends today, it seems that you are up for the largest re-engineering of the grid in probably 100 years. How you are addressing this gigantic challenge?
Yeah, it's a huge challenge. Thanks, first of all. And I agree, first of all, also with the previous speakers. I think this is a joint challenge that we have here. If we even look further than 2030 to 2050, of course, the provisions, let's say, to have 90% of the energy even in renewable and over 50% electrified. And if you look at those numbers, the challenge, in fact, is, just for those who do not know how grids work, is to really match during the day the energy flows that are completely different. And sometimes they come from one area to the other, in another time of the day at night, the other way around. And you have electrical cars that charge in different points. And you have a huge complexity that needs to be managed. And the only way of doing this, and that comes back to your question, is digitalizing the grid. So that means digitalizing the infrastructure, digitalizing the sort of revamping kind of this old infrastructure through digital technologies, control technologies, and data sensors and so on. You need to digitalize as well, let's say, the grid edge, so the interface kind of towards the consumer, towards the customers, towards the other players in the ecosystem. And you need to digitalize as well your own workforces internally, and to have a maximum efficiency, to be resilient, efficient, and to achieve this trilemma that Michaela was saying before. So really the key is digitalization, and that is the challenge. And also coming back to the regulatory part, this is the challenge, of course, for the electrical distribution companies. The challenge is not to digitalize, because we have the technologies, but it's of course to be able to do this in very fast, to the short time frame that we have. On the other side, also do it in the most efficient way, also of course together with the right scheme that at the end benefits the whole electrical ecosystem. So that is, let's say, the big challenge, really to get to this complete transformation, complete digitalization of the grids.
Sounds huge. Let's go back to Gabriel. Let's assume that in 2 to 3 years we have a digital, network on the other side that can interplay, Can interplay with your customers, with the flexibility. How would you envision, Gabriel, this interplay with your customers to minimize the total cost, for families, energy, grid, and own production, The minimum total cost.
Well, Robert said it very well. So at the end, this big problem has different solutions. One comes from the grid, so we need that visibility, we need that manageability, and we need that grid which is meshed, which is no radial grid, so you can direct the flows whenever you want. So on the other side, you have the customers. And the customers, what they need is something clear, which is probably the role of the energy suppliers, which is we need to make this complex energy revolution very simple. We have to make the energy more easier and cheaper every time. So and that's the role of I think the companies that we are playing, especially the what is called the new downstream. So what is called the solar, is batteries and all these distributed generation. So what we are doing is, okay, we have to start with layers. We're going to install solar in the homes, and the homes are going to, now the tariffs are going to work differently than every day, which is only plugging the lights. Now, on top of that, we're going to put the batteries. But on top of that, we're going to put the charging of the car. And on top of that, we're going to put, for example, the heat pumps. That is absolutely impossible to manage by a person. So you have to envelop everything by the intelligence. You have to give this huge complexity to the client with a very simple interface. So at the end, you have to introduce intelligence. Intelligence can working together with all these elements, but also working together with the grid. So now you are consuming energy, but in 10 minutes you are producing and generating, and then, so the pace of sophistication is going to go so quickly that it is impossible to follow by consumer. Consumer at the end has to find that the solutions are easy to understand, and the solution always become cheaper and cleaner. And I would say, you talk the grid, you talk about the companies, the consumers, but also I would like to make a special attention to startups. So I think that this disruption cannot come only from the old players. So we need startups, we need companies like PlexiGrid that bring new ideas, new challenges, new technologies in order to exactly this. So pile complexity, make it more simple to the client and more tractable and manageable to the grid. So it's an amazing future.
Interesting, absolutely. Exciting and scary at the same time, but we will figure it out. Michaela, how will you envision, from where you stand, from a hydrogen revolution, green hydrogen revolution, about to explode. That on one hand, it puts more pressure onto the grid because it consumes a lot of green electricity, but on the other side, it could also be part of the solution, right? How will you envision this interplay of this hydrogen network with a digital electricity network?
Well, in this vision of the future, hydrogen is, again, it's an energy vector, so it's solving those needs that electricity, the renewable electricity is not solving. And as an energy vector, it's also a storage element and a transportation element for renewable electricity. So it's actually an integral part of helping to balance the grid and also facilitating the penetration of renewables in the grid. Because eventually, you can use hydrogen to carry renewable electricity from places with great resources like Spain, Australia, Latin America, to cities thousands of kilometers away that are hungry for energy. You can use hydrogen, there is promise in hydrogen as a storage element, and as I mentioned before, for days, for weeks, maybe for months.
Yeah.
What we need to be doing is building up the infrastructure and the interconnectivity that's going to make that happen. Yeah. Those are the potential roadblocks and the challenges that we're going to need to overcome, because we need to increase the areas that are interconnected and where we're balancing, supply and demand. And we also need the infrastructure, like I mentioned before, not only the electricity grid, but also we need to start retrofitting the gas pipelines so that they can carry hydrogen. And obviously, we need regulation. Yeah. Everybody who wants to invest in this is waiting for the regulation and the standards for an international market.
Very good. Carlos, the ball keeps coming back to you, the regulator, right? Give us a little bit of wisdom, right? I mean, you don't have to disclose any confidential things that you're cooking in the ministry now, but what are the main lines of regulatory development for the coming years that you will work with?
Yes, I think in this field, as in many others, the government usually goes behind the private sector. So it's hard for us to cope with all the new things that come, but we have to make an effort to think in what will the energy sector needs for 2030 if we want the transition, the energy transition to happen. And in that way, one useful tool for that is the use of regulatory sandboxes. They have been used also in the financial sector with big success. So this idea is something that we want to promote also in the energy sector, so we can do things at a smaller scale to check if they work, and then we can expand it to the whole system. And at the same time, another important thing that we have to work with in the grid is the role of the distributor. As I said before, we have to change, and the distribution company are going to be more a system operator of their own grid. So they have to manage it in a way that they can cope with all the renewable production that they have, and they offer enough flexibility to their clients, their customers.
Okay, Robert. Yes, the ball back to you. I would like, we discussed before, right, where we were getting ready and testing the microphones that were not working and so on, but we said, well, maybe we can, some of the technologies that we're going to need are actually not being taught in electrical engineering universities, so to say, right? I mean, it seems that the electrical engineer of the future will be more of a big data scientist with some electricity knowledge, so to say, right? And you just say that digitalization of the grid will be the biggest part of the transformation, making it intelligent on real time and all of that. What will be your message? I mean, we have many startups today, not only many from energy, but some from other fields, right? Like big data or artificial intelligence. What will be your message from Enel to all this ecosystem of innovation and startups in the grid transition? What's in it for them?
Yeah, I think, well, first of all, at Enel, we just created actually a new coincide, let's say, that we call Gridexpertise. That is, let's say, the expertise for the grid that actually helps internally, but also externally, the companies, the to become the distribution system operator by digitalizing the grids, right? So this full transformation of digitalization. And this can be only done also, of course, apart from the knowledge that we at Enel might have, because for 20 years, let's say, we are pioneering, let's say, digitalization in different fields. But of course, you do this together with partners. So you need an ecosystem. And there's a lot of room as well for the collaboration with innovative partners, with startups. And as you said before, today, in fact, it's not so much the electrical knowledge, the electromechanical knowledge that is required, of course, as well as part of it. But you need to look at the data. At the data, you need to be more efficient. You need to do predictive analysis, let's say, based on, let's say, big data that you get from sensors that are installed in the grid. You need to have telecommunication capabilities to really make usage of the newest technologies in order to make best use of low latency, for example, or high data volumes. You need all the IT skills that you basically put together the different information that comes from so many different points, from the renewable, the, let's say, EV, grid internal, and all of that needs to be, let's say, controlled, managed in real time in an automated way. Right? So you need to have those skills there, and there's so everything that is related to sensors, to digital technologies, to artificial intelligence, to anything related to big data, or let's say also material science even, because we look at, of course, to doing this transformation using sustainable ways of doing it. So when we look at digital control elements that are at the end installed in the grid, they should be, let's say, designed in let's say, towards a circular economy, so that they can be reused, and the whole life chain, let's say, is looked at. Because if the overall ambition is, let's say, becoming net zero, that needs much more than just, let's say, putting the energy pieces together. It really means a complete transformation, also in thought of what is going on. And I think in all of those schemes, startups are really great, because startups are really dynamic, have the open mind, might look at this very small sector or a very small problem, but there, as I said before, there are so many problems to be solved, let's say, together, and all of those different pieces are easier to fit in today than it was before, because today you have this digital ecosystem that glues everything together. Before it was really, let's say, just could bring something, a mechanical device or something like that. Today it's really everything from mechanical to digital to whatever I mentioned before. You can put together and glue this, and so from our side, of course, we work a lot in an open innovation fashion with startups, and if those who are here are interested, have any ideas, we're always open to listen, to collaborate, and I'm sure there are opportunities to do this for the energy sector, and might be ideas that even come from completely other sectors.
Wonderful. Well, thanks for that. And we certainly need fresh ideas here. I think it was Albert Einstein who said that you will never be able to resolve a problem with the same mindset that created it in the first place. So I think we are going to need a lot of outside-in innovation into the electricity sector, and it's great to see Enel championing that and bringing this in. Time flies. We hope you enjoyed the panel, and well, there's no time for questions, but most of us will be hanging around after the panel. So if you have some questions or suggestions, you can address us. Thank you very much.
Okay. Thank you.
Thank you.
Thank you very much.